everyone. Today we're going to learn about kinematics and projectile motion, the formulas associated with it, and how to use those formulas. What is kinematics? Kinematics describes the motion of an object. Let's take a look at an example. Ball. This ball is in motion now. By learning kinematics, you can relate displacement, velocity, acceleration, and time without referencing to the cause of the motion. Before we get to the formulas used in kinematics, let's learn the difference between scalar and vector quantities. Scalar quantities are fully described by magnitude only, such as example, distance, speed, time, etc. On the other hand, vector quantities are fully described by both magnitude and directions. Some of the examples are displacement, velocity, acceleration, etc. Let's take an example to find out the difference between scalar and vector quantity.
Suppose the bottle is rolling at a speed of 5 meters per second. Then here the speed 5 meters per second is a scalar quantity, as it only tells us about the magnitude. But if we include the direction, such as the bottle is moving at a speed of 5 meters per second in north direction, then it becomes the velocity of the bottle, which is a vector quantity.
Now let's learn one by one about the components used in kinematics. Okay, we have distance and displacement. Okay, the first figure is distance. This is the starting point and this is the end point. Now if we talking about distance, we're going to measure the length of this line. Okay, but displacement is the shortest distance between 2 points. So we're just measuring this distance. Now what instrument are we going to use to measure this distance? We can use a ruler or we can also use a tape measure. Okay, the second figure is, it looks like a mountain. So this is the starting point and the end point. Distance is the length of this line, okay? But the shortest distance between the 2 points is what we call displacement. Moving, like for example, from the starting point you move eastward, let's say 24 meters and 7 meters northward. Now what is the distance traveled by you, for example? So that's 24 plus 7 is equal to 31 meters. But if you're talking about displacement, it has to be the shortest distance between the 2 points. Okay? So how will you measure it? By using the Pythagorean theorem. So it says here, d sub r is equal to the square root of 24 square plus 7 square, which means the square of the legs of the right triangle. So 24 square is 576 plus 49 is equal to the square root of 625, which is equal to 25 meters. So the shortest distance between these 2 points is what we call displacement, and is equal to 25 meters.
The next component of kinematics are speed and velocity. Speed is the rate an object is moving without regard to direction. To understand better, let's review the earlier example, which was the rolling of bottle. The following example will show how to find the velocity of a moving object. Let's roll this bottle, find out the time it takes from the starting point until it stops. And also, let's measure the distance. Let me start the stopwatch. 29.8 seconds. Now let's record the distance is covered from the starting point till the ending point. Okay, it's 176 centimeters. 176 centimeters, which is 1.76 meters. Now let's find out how to get the velocity. Okay. 176 centimeters is equal to 1.76 meter. Time it took from the starting till the end is 29.8 seconds. Velocity is equal to displacement over time. Our displacement in this case is 1.76 meter and the time it took was 29.8 seconds. If you divide these two factors, we'll get 1.33 meter per second, which is our velocity. So velocity and speed, they are both related, but one is a scalar quantity and speed is the scalar quantity, whereas velocity is a vector quantity because it has a direction.
An important component used in kinematic is acceleration. Acceleration is the rate of change of velocity per unit time. It is denoted by A and measured in meter per second square. So if you see this, it means acceleration, and it's measured in meter per second square or feet per second square.
Now that you know all the components used in kinematics, let's gain knowledge of an object in projectile motion. Projectile motion is the motion of an object in vertical and horizontal direction. An example is a ping pong ball launched from a catapult.
Okay, now we're going to do an experiment, like we're going to use a catapult and a ping pong ball. We're going to launch the ping pong ball in a catapult like this. Put it this way. And
The formulas used in calculating various components of a body in projectile motion are
Now we are going to apply the above formulas to find out the initial velocity of a ping pong ball launched from a ballistic device. This is a ballistic device. This is the launching station where we're going to put the ball and we're going to launch from here. This portion is kind of a protector which shows various angles we're going to fire. So that angle can be measured from here. Okay? Supposedly, or you can use a protector to measure this angle. That's the same angle. Now to find out the initial velocity, as we spoke, we need to find out the angle. So from the protector, I'm getting a view of 30 degree. I'm going to launch this ball at an angle of 30 degree, then record the time here, and then find out the distance. It took approximately 30 seconds. So let's first record those two values. The angle at which we fired the ball was 30 degree. The time it took from the launching station to hit the ground until it stops is 30 seconds. Now let's measure the displacement. This is 1 meter. to 3 meters and 30. So 3.3 meters. This is how you calculate initial velocity, or use different formulas to find out the time it takes, or the angle of firing angle, or the initial velocity of any projectile object. Okay, from the experiment, our known values we found. Theta, which is the firing angle, is 30 degree. The time it took from the launching station to hit the ground and until it stops is 30 seconds. Displacement x is 3.3 meters. So these are the three factors which we got by launching the ping pong from the velocity device. And our unknown is the vi, which stands for initial velocity. This is the formula we're going to use, and after plugging the values, g is 9.8. Because we are using everything in metric, that's why g, the acceleration due to gravity, is 9.8 meter per second square. If we would have used the English system, then g would have been 32.2 feet per second square. So since we are using the metric system here, our g is going to be 9.8 times x, which is the displacement, is 3.3 meter, and theta is replacing theta with the 30 degree value. This is what we are going to get. After simplifying and multiplying these two factors, it becomes 3.33, and the sine 2 times 30 degree is equal to 0.866. And taking a square root of that one, the final value, which is the vi, initial velocity, is going to be 1.96 meter per second. So this is the initial velocity. 1.96 is the meter per second, is the velocity at which the ping pong ball was launched from the velocity device.
Since you learned the concept of kinematics and projectile motion, let's practice by solving this problem. Do you know that the concept of kinematics and projectile motion is extensively used by Department of Defense to protect United States and their allies? Remember the Gulf War in 1991, where the American forces used a Patriot missile to intercept the Scud missile launched by the Iraqi forces?